Hello guys, my name is Bino. In this video, we have the following information given about a quadratic number pattern where term number 1 is equal to 3 and term number 2 minus term number 1 is equal to 9 and term number 3 minus term number 2 is equal to 21. 2.2.1 we show that term number 5 is equal to 111. So the first term is equal to 3 and we are not given term number 2, so we denote it with T2, and we are also not given term number 3. We are not given term number 4, and we have to determine term number 5. But what we are given is that term number 2 minus term number 1 is equal to 9, and that term number 3 minus term number 2 is equal to 21. And we have to determine term number 4 minus term number 3 and also determine term number 5 minus term number 4. But for now, the 21 minus 9 is equal to 12. And we denote term number 4 minus term number 3 with the letter X, and term number 5 minus term number 4 with the letter Y. So X minus 21 will be equal to 12, and Y minus X will also be equal to 12 since we have a quadratic number pattern. And here we can realize that the 9 plus that 12 will be equal to 21. And also, we expect that the 21 plus that 12 will be equal to X. So 21 plus 12 is equal to 33. And we expect also that the 33 plus that 12 will give us the value of Y. So 33 plus 12 is equals to 45. So in the place of the Y, let's substitute 45. From here, the 3 plus the 9 will give us term number 2. So 3 plus 9 is equal to 12. So in the place of the term 2, we substitute 12. In the same way, we expect that the 12 plus that 21 will give us term number 3. 12 plus 21 is equal to 33. So in the place of the term 3, we substitute 33. And in the same way, the 33 plus that 33 will give us term number 4. 33 plus 33 is equal to 66. So there we substitute 66. And finally, the 66 plus that 45 will give us term number 5. So 66 plus 45 will be equal to 111. So we have proved that term number 5 is equals to 111. 2.2.2 we show that the general term of the quadratic pattern is Tn is equals to 6n squared minus 9n plus 6. For a quadratic number pattern, we have 2a is equals to the second difference. So 2a will be equals to the second difference is equals to 12. So in the place of that second difference, we substitute 12. And to solve for a, we divide both sides of the equation by 2, and from here the 2 and that 2 will cancel out, and the value of a will be equals to 12 divided by 2, which is equals to 6. And for a quadratic number pattern, we know that 3a plus b is equals to the first term of the first difference. So we have 3 into a. Our a we just determined that it's equals to 6 plus the b, and this will be equals to the first term of the first difference is equals to that 9. So we substitute 9. 3 multiplied by 6 is equals to 18 plus b is equals to 9. We move the 18 from the left to the right. It will change sign to negative 18. So the b is equals to 9 minus 18. 9 minus 18 is equals to negative 9. And for a quadratic number pattern, we have the a plus b plus c is equals to the first term. We determine that the a is equals to 6 and that b is equals to negative 9, and we have to determine the c. The first term of this quadratic number pattern is equals to 3. Six minus 9 is equals to negative 3 plus c is equals to 3. So our c will be equals to 3 plus 3. So c is equals to 6. So we have Tn is equals to an squared, but our a is equals to 6 plus bn, our b is equals to negative 9 plus c, and our c is equals to 6. So we compare. Yes, they are the same. So we have shown that this quadratic pattern is equals to 6n squared minus 9n plus 6. Question 2.2.3, we show that the pattern is increasing for all n is an element of whole numbers. So the capital letter N, whole numbers, just means that anything greater than negative 1, which is not a fraction. Remember that n starts from 1 and it's never a fraction or a negative number, it's always positive. And since the coefficient of the n squared is a positive, the Tn will take the following shape when drawn, and we have our turning point. From the turning point going up, Tn is always increasing. There are two scenarios that we can have for n is equals to 1. So it's either n is equals to 1. The first scenario is that n is equals to 1 is on the right side of the quadratic turning point, and the other scenario is that n is equals to 1 is on the left side of the turning point. If n is equal to 1 is on the left side of the turning point, then Tn will decrease. And after the turning point, it will increase. But if n is equal to 1 is on the right side of the turning point, then Tn will always increase. So our duty is to prove that n is equal to 1 is on the right side of the turning point. So we have to get a turning point which is less than 1. So for the turning point, we have x is equal to negative b divided by 2a, but the independent variable in this case is not x, it's n. So n will be equal to negative into b. Our b is equal to negative 9 divided by 2 multiplied by a, where the a is equal to 6. Negative multiplied by negative 9 is equal to positive 9, and 2 multiplied by 6 is equal to 12. Our n will be equal to 9 divided by 12, which is equal to 3 divided by 4. So at our turning point, we have n is equal to 3 divided by 4, which is equal to 0.75. We have that as our turning point, and we have n is equal to 1 somewhere there. Since n is equal to 1 is on the right side of the turning point, so Tn will always be increasing on the right side of the turning point. So by proving that n is on the right side of the turning point, we have proved that Tn will always increase for n is an element of whole numbers.